So, another nice quadratics question. A ball is kicked from a cliff top. I think this is such a control question. Who would ever do that? Anyway, the height h meters of the ball relative to the cliff top after t seconds is given by this. First step, write this out. These sort of questions, I found them quite confusing. When I first did them, I was like, not too sure. Especially part B, which we'll get onto in a minute. But once you see it, you can't unsee it, guys. So, anyway. Calculate the height of the ball above the cliff top after 2 seconds. So, we know that height is h. Here's our h. And we know we're given this piece of information 2 seconds. Now, let's reread this again. The height, h meters, blah, 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 10 t seconds. So, we're guessing that our unknown here, we have our h, which we know is height, and t is seconds. T represents seconds. So, we substitute 2 for t. So, height is equal to 12 times 2 minus 5, 2 squared. Now, just be careful, guys. That squared does not apply to that 5. If it did, it would be written like that. But it is not being applied to that 5. So 12 times 2 is 24, minus 5 times 2 squared. Okay, so we do the squaring first, bond mass. 2 squared is 4, so 5 times 4. Height is equal to 24 minus 20. Height is equal to 4. So I would write height is equal to 4 meters. Okay, so now on to part B. The graph below represents the height h meters of the ball relative to the cliff top after t seconds. So this initially can be slightly confusing. Why are they giving us 2 graphs? But guys, this graph here is just exactly the same as the picture above. Okay, so I'm going to draw on this just to make this really clear what this is, because this is a hard question, guys. I just had to go and pause to make sure what I was saying was correct. So here's this is the sea. The sea is 17 meters below the cliff top. In the picture, our man was here, and this was the cliff, so T was our cliff top, and then he kicked it like that. Okay, so, and we know this, as I said before, we know this is a quadratics question, because we were given a quadratic equation. Now, the sea, after how many seconds will the ball hit the sea? What does that actually mean? So we know that t represents seconds. So we can think of t as our x-axis and height as our y-axis. So after how many seconds will the ball hit the sea? So it's looking for an x value, i.e. a t value. See? It hits the ball here and it's wanting to know after how many seconds. So it wants to know the value, if that was actually a straight line, that lies here. It wants to know an x. And guys, hallelujah, we know how to do that. We can factorise. So, but we need an equation to factorise first. So, we look back to part A of the question. We need to make ourselves an equation. So we have this piece of information here. So, height is equal to 12 times t minus 5t squared. We're looking for t. Can we find that? Well, yes we can, because we have h. Because here we are. However, what is our y value? Well, we know it, because this is the point we're trying to find if this was a graph. And then we have negative 17. So, you can just think of it like this. When h is equal to 17, well, it's quite easy really. When y is equal to 17, what is x? So how would we write that? Let's put this into an equation. We know that, go back again because I remember it, 12t minus 5t squared, 12t minus 5t squared is equal to negative 17. Negative 17 is our height, that's why that's there. And then 12t minus 5t squared is just the equation of this parabola. And all we need to do is find the x-coordinate, i.e. the t-coordinate, of the point. So how would I do this? Well, I'm going to factorize this in real time. It's not a pretty one, guys, but I'm going to set it equal to 0 just to make it nice and easy. 5t squared plus 12t plus 17 plus, because this 17's come over to the other side, is equal to 0. Now, I know that that doesn't divide by anything nicely, but fortunately we have a 5, and 5 is a prime number. So one of these is 5 and one of them is 1. That much we know. One of them is also going to have to be negative. So I'll probably just do, let me see, 17. 17. Yes, 17 is also prime, guys. And I do not want to be doing 5 times 17. So 17 add 1. So I need to do negative, positive. Let's try that. Oops, 7. Oh, don't forget your t's, guys. Like I did. Fool. 5t times, use the blue pen. So let's check if this is correct. Negative 5t times 1t is negative 5t squared. Excellent. Negative 5t times 1 is negative 5t. Next one. Now we do 17 times 1t is positive 17t. And then finally, 17 times 1 is 17. So if we collect that, we get negative 5t squared stays the same. We have negative 5t plus 17, which gives us positive 12t. And then we have a positive 17 at the end. And that is the same as this, which means we've done it correctly. Now we can go down and solve for t. And we're going to get two answers here. So, negative 5t plus 17 is equal to 0. Negative 5t is equal to negative 17. T is equal to 17 over 5. Positive, because a negative divided by a negative is positive. Maybe just draw a nice line down there. So 1t plus 1 is equal to 0. 1, wait, we don't even need 1t, do we? No. T plus 1, that's bad form, self. T is equal to negative 1. Now, we've got two answers here, but which one is correct? Well, let's look. We can use the graph to help us. Well, the graph will actually downright inform us, make it blatantly obvious which one is correct. So we have t is equal to negative 1. Negative 1 is probably here, but the ball hits here, so t is definitely not negative 1, is it? Put an x beside that answer to communicate that. That's not plausible. So, but is 17 divided by 5, because 17 divided by 5 is, so 17, just quickly did this, convert this into a mixed fraction, 17 over 5. Well, we know that 3 times 5 is 15, plus we have 2 left over, 3 and 2/5. 2/5, well, that is equal to 0.4, because if you divide 100 by 5 you get 20, i.e. 0.2. 0.2 times 2 is 0.4, so we have 3.4. Is 3.4 plausible? Well, yeah, it is, because we knew that this was 2. And if we just eyeball approximately, somewhat, yes, that is plausible, that is 3.4. Moreover, this is positive answer. And since our little person did not kick the ball behind him, then that is our answer. After how many seconds will the ball hit the sea? The ball will hit the sea after 3.4 seconds. And smiley face. Congratulations if you've been following along, or tears. It could be a face of anguish right now, guys. Anyway, if you've been following along, give yourself a pat on the back. And that is not sarcasm. It's genuinely not, because you're taking initiative to better yourself, and it's not about being better than other people, but taking responsibility for your future. Then I'm not going to bore you with my life story, but I admire you guys, so well done.
Thank you for watching. I really appreciate it, and I appreciate your patience and bearing with me on this last question. Bye.